Hey everyone, Jersey Mike. Today I'm going to share with you 11 temperature readings pretty much anybody can take to determine if your AC system is running properly, healthy, and efficiently, or if there are issues going on that need some attention. So what we're going to do is we're going to begin by going right up to the thermostat. We're going to set the air conditioning set point down below room temperature at least 4 or 5 degrees. And the reason why we're doing this is because the first two measurements we're taking are highly dependent on proper airflow, and we want to make sure our system is running at full capacity when we do this. If you have a multi-stage system, 2-stage cooling, if you have variable speed blower motors and things of that nature, dropping that temperature 4 or 5 down below room temperature will ensure your system's running at full capacity so that we get precise measurements to work with. Now the first two temperatures we're going to take is called delta T in the trade. This is the temperature difference of our indoor unit, the air coming in and the air leaving. Usually we take these temperatures right in the ductwork itself as close to the unit as possible, but for practical purposes you can do it at your return and supply grills right in the living area. So the first measurement we're going to take is at the return grill. This is where the air from the home enters into the duct system and starts heading towards the indoor unit. For a lot of people this is the same place you change your filter. Once you have a stable temperature there, what you want to do now is take the temperature of the air coming out of the system. This is the cold air coming out of your vents. Now what you want to do is you want to pick a vent that is close to the unit as possible. So if your air handler is located in the attic above a certain bedroom, you want to go to that bedroom and measure the cold air coming out of the vent there. The farther away you are from the unit, the less accurate of the reading that you're going to get. Once you have these two temperatures, you want to compare the difference between them. Now on normal systems, in most cases, we're looking for a temperature difference between 18 and 22 degrees. Now this 18 to 22 degree difference is highly conditional on airflow, which is why we made sure our system is running at its full capacity. If their temperatures are outside of this range, there's a couple of explanations for it. Some are good and some are not so good. One of the things you want to take in consideration is the humidity level in the home. If your system was off for a couple of days, it's really humid in the house, and that humidity level is really high, it means you probably have a very high wet bulb temperature, which means that you're probably not going to get close to that 18 to 20 degree difference you're looking for. All that extra humidity in the air is going to keep that number pretty low, and that is not an indication that your system is running improperly or inefficiently. It's just a conditional situation. So if that is the case, you want to let your system run for a few hours, let it acclimate, and then try taking those measurements again. Now if you have a temperature that exceeds that 22 degrees, it usually indicates that the airflow across the evaporator coil may be too slow. This can be for multiple reasons. This could be you have an issue with the blower itself, it could be a dirty evaporator coil, it could be a very dirty filter, but something is slowing down the airflow when it should be running at full capacity, and these excess numbers are cluing you in that there's an issue that needs to be looked at. Now sometimes it can also be a system that's simply overcharged. There's just too much refrigerant in it. Now the next two measurements we're going to take are outside on the outdoor unit. What we're going to do is we're going to take a temperature of our suction and our liquid copper lines going into the unit. Now this is a surface temperature reading, so you want to make sure you're using a device that reads surface temperature. Now what we're looking for here is very simple. We're looking for a temperature difference between these two lines, anywhere between 15 and 30 degrees Fahrenheit. Anything more than that or less than that can indicate there's a problem in the refrigeration cycle somewhere. It could be a problem with the compressor, a TXV, a plugged line somewhere, or a kink line set. The next two measurements, you may or may not have one, but if you have a filter dryer in the smaller copper line, you just want to measure both sides of that filter dryer immediately on one side and the other. If you see any more than a 1, maybe 2 degree difference, that could be an indicator that the filter dryer is plugged and you have a problem with flow in your refrigeration cycle. Now these filter dryers, many times you'll find them right outside on the smaller line set on the condensing unit outdoors. Sometimes you might actually find them inside just before the copper goes into the air handler. Now the next two readings I'm going to share with you guys are not readings that technicians normally take for diagnostic purposes. This is something I just do out of curiosity every time I'm running maintenance on a system or doing a startup or anything along those lines. And that is the temperature entering the side of the outdoor unit and the temperature coming out of the top of it. And generally what I see between these two temperatures is about 10 to 15 degrees. Now as a technician that doesn't really mean anything, and to really explain what that temperature means I would have to get really highly technical about it, but in a nutshell, most of these subcooling target temperatures for 410A systems is about 10 degrees, sometimes 12, sometimes around 9, but it's usually around 9 to 12 degrees. If I take that subcooling and I add it to the temperature difference coming in and coming out the outdoor unit, and I add those two together, if it falls between 15 and 30, I know I'm in pretty good shape. What you don't want to see is a temperature difference of 0. You know, coming in the side and coming out the top, that means something's not working. It's probably your compressor's not running. Now the next two temperatures we want to take is the outdoor temperature and the indoor temperature with the system running. A properly designed system is usually not going to do any better than a 20-degree difference. This is also a good indicator to know whether or not your system is running properly on a very hot day. If you have a 95-degree day and your system's not getting down below 75, rest assured your system is doing everything it's supposed to be doing and it just doesn't have any more. Now there's a reason for this. The last temperature we're going to look at is design temperature. This is kind of behind the scenes kind of thing. It's something people who actually design systems look at. It's a manual J load calculation kind of thing. But basically what all that means is that wherever you live, there is a design temperature associated with that location. So as you can see here, I'm on Google. I typed in HVAC design temperature database, and what you're looking for is the ASHRAE climate design conditions. We're going to go ahead and click on that. You see a nice map pop up of the world, and what all these blue dots are, these are all weather stations that record data and temperatures and all that stuff. So you want to click on the most recent year, 2021. We're going to click on that. We're going to click on show all stations. We are going to check off our measurements, either standard or imperial. I'm going to do imperial, and then we will click on map. And so what we want to do is you want to zoom in on your location. We're going to zoom in on Jersey Mike's playground here. We're going to go, let's go with Newark International Airport. Where is it? There it is. All right, so this is the temperatures that are taken at this location at every single day over the course of the year, year after year after year. Highs, lows, median temperatures, all that stuff. So once you select the data point close to where you live, what you want to do is you want to scroll down, and we're going to look for hottest month. All right, that's 7, that's July. We're going to come over and we're going to look for 1%. All right, now we're also, this is the number we're looking for here, this dry bulb, this 91.1. So basically what this means is 1% of the year, the temperature will exceed 91 degrees in this location. Now the reason why I'm pointing this out is because properly designed systems use this number to design how the system is going to function in the home. So basically, in a nutshell, what I'm telling you here is that a system that's properly designed is not going to be able to handle temperatures above 91 degrees, because if we did design a system that was capable of handling temperatures higher than that, what you're going to have is an oversized system. And with oversized systems, you lose a ton of efficiency. You have humidity problems because it cools the home too fast without removing humidity. You end up with mold problems. This is something we want to avoid doing in the HVAC industry. So that's why we use these design temperatures. So what this basically means, if you have a 98-degree day and you think there's a problem with your system because it won't drop below 80 degrees, you don't have a system that's doing anything wrong. You just have a system that wasn't designed to do that. And while that's certainly an inconvenience on the hottest days of the year, it's actually preferable to having an oversized system that brings a whole slew of problems the rest of the year. Now just keep in mind, none of this is really for actual diagnostic purposes. I'm just giving you guys the information you need to kind of determine whether something is right or wrong with your system and when it's time to take a closer look at things. Hope you guys picked up something from that one. Thanks for watching.